answers to these questions, but we're going to discuss them in case anyone got stuck. The pH scale. You should have heard of it at one point in your life. What is the pH scale? What does it measure? Good, Angelina. Angelina popped up with it. The pH scale, it's a scale, it measured acids and bases on a scale from 0 to 14. So just like if I ask you on a scale of 1 to 10, how much do you like tacos? You would give me either one side or the other. You hate them and it would be a 1, and you love them, it would be a 10. The pH scale is a scale from 0 to 14, measures acids and bases. All right, so who looked up what is a neutral solution? What number on the pH scale is a neutral solution? 7, very good, Angelina. What about an acid? It's a range, but do you know what numbers between 0 and 14 are acids? 0 to 6, very good. And then what about bases? What numbers on the scale are bases? I know Angelina knows because she's answered all of them. Good, 8 to 14. That's part of our notes today. So if you didn't get that, you will get it as we go throughout. And then examples of an acid and a base. Acid is easy because a lot of foods are acidic. What foods have acid or drinks have acids in them? Soda, yep, Shayla, very good. Limon, yep. Lemon, lime, oranges, citrus fruits are acids. Good. What about bases? Can you guys name any bases? No, water's not a base. Milk actually has acid in it, lactic acid. It's a little bit acidic. Baking soda is a base. It's like your most basic kitchen. Well, Desiree, that's why you're learning. That's why we're learning about it today. In about 10 minutes, you'll know all of it. So baking soda is a base. There's other ones, but baking soda is the most common that you would have in your house. Cornstarch is a base, yeah. Good. All right. So moving on, our essential question is the same. What are living things made of? We talked about elements last section. Our 6 most common elements are schnapps, carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. You put those elements together, you get various compounds. And our most common compound is water. Water's unique properties allow life to exist on Earth. If we want to colonize another planet in our solar system, in our galaxy, it has to have water. Without water, there is no life. The Mars rovers have discovered water on Mars, or not currently, but that there used to be water on Mars millions of years ago. But there's not anymore. So many compounds dissolve in water. Water will take in a lot of different things. If you go to the beach and you go swimming in the water, there's other stuff just besides water in there. If you taste it, what does it taste like? What does beach water taste like? Salt, yep, very good. So that salt is dissolved in the water, not the other way around. So a solution is formed when one substance dissolves into another. So like beach water, the salt dissolves into the water. In your kitchen, you can make Kool Aid. Everybody, I think, has made Kool Aid before. If not, you're going to learn how today. Our official science name for the water is called a solvent. A solvent, it dissolves the other substances. The solvents take in the other substances. That's water takes in the other substances. Water is the universal solvent because it dissolves almost anything. Not everything, but a lot of stuff. And then solutes are the name of the powders. They dissolve into the solvent or into the water. If you're making Kool Aid, you got powder and you have sugar. The powder and the sugar get dissolved and the water takes them in. So you got three words, they sound the same, but they mean different things. The solution would be the whole thing all together. And the solvent and the solute are the different parts, the different particles, if you look at them up close. Water is the universal solvent, and the solute, in the Kool Aid case, it's going to be water. If you go to the beach water case, it's going to be salt, because that dissolves into the water. Separation of water. So we know water is H2O. There's 2 hydrogens and 1 oxygen. But those molecules, those elements can separate from each other. They don't always stick together. When you separate them, a hydrogen will float to one side, and then another oxygen and hydrogen will float to the other side. And they each keep a charge, which is why there's a little plus and minus afterwards. And if an element is charged, has a plus or a minus charge, it's called an ion. So if you have more hydrogen ions, you can see in the little cloud, then something is an acid. If you have more hydroxide ions, that's the OH minus, the official name for it, then a substance will be considered a base. And pH is actually the mathematical expression of hydrogen ion concentration in a solution. So yes, it measures acids and bases, but it does it by measuring the amount of hydrogen there is. Too much hydrogen, you make something an acid. And becoming an acid is not always a good thing. You put too much acid in the ground, then fruits and vegetables and all the stuff we farm and we grow in the ground doesn't grow very well. You put too much acid in ocean water, then it dissolves a whole lot of just tiny little animals. And there's a lot of sea animals that feed on things that will be dissolved. When we talk about climate change, we're going to talk about ocean acidification, putting too much acid in the ocean and what it's doing to the animals in the ocean. No, this isn't the first page. The pH scale, like we said, it's a scale from 0 to 14. Acids have a pH value of less than 7. Contains more hydrogen ions. Bases have a pH value that is more than 7. Contains more hydroxide and less hydrogen. And you can see on the scale, your stomach acid, when you swallow food, you have acid in your stomach that helps break down the food. It's about a 2 or a 3. You also have a substance in your body called bile. It comes out of your liver, gets stored in your gallbladder, and helps you dissolve fats when you eat fatty foods. Bile is basic. It has a pH value of between 8 and 9. So most of the time our bodies like neutral things right at 7, but there are substances in our bodies that help us break down food that can be on the acidic or the basic side. A neutral solution has a pH of pretty much exactly 7. It could be a decimal, 7.3, 7.5. Water is a neutral substance. Water in its natural state is a neutral substance. Humans have put different things into water to try to make it one way or another. but it's supposed to be neutral. No, you don't have to draw the pictures. If I want you to draw something, I'll put draw on the slide. There's no drawing in here, in these slides. Measuring pH. Scientists have special paper called litmus paper. I actually have litmus paper in the classroom, and if we were in class, we would be playing with it. So hopefully when we get back, we'll be able to play with it. There's red litmus paper and blue litmus paper. And they change colors. They're called indicators. They will indicate either an acid or a base. Red paper will turn blue if you dip it in a base. Blue paper will turn red if you dip it into an acid. And then polar versus nonpolar. These are terms to describe a molecule. We're talking about water for this section, so we're going to use them in reference to the water molecule. You got H2O. There's a representation, a picture at the bottom. No, you don't have to draw it. You can just look at it. The bonds between oxygen and hydrogens in the water molecule are not even. Oxygen pulls electrons more towards it, which leaves the hydrogens with a positive charge. This makes water a polar molecule. Just like the Earth has a North Pole and a South Pole, they're opposites. The water molecule has a negative pole and a positive pole. The oxygen is the negative side. The hydrogens are the positive side. So we call it a polar molecule because it has two opposite poles. There are plenty of atoms and compounds that don't have charge, that the charge is evenly distributed all the way around. Those are the opposite. That's what we call nonpolar because there are no poles. Viviana, I don't know what you mean. If it's not acidic, it's either neutral or basic. So you have three categories. You have an acid, a base, and a neutral. The papers, so if neither of the paper changes, they're neutral. So if the acid doesn't change to a base and the base doesn't change to an acid, or the red doesn't change to blue, blue doesn't change to red, then it's neutral.